Hello students, so let's just talk about isomorphic graphs. So what are the isomorphic graphs? Two graphs are said to be isomorphic if there exists one-to-one correspondence, that is, there exists a function from vertex set of a graph G to vertex set of the graph G star such that the edge of G is mapped to edge of G star. Like suppose in this graph you can see this edge is being mapped to this edge. Okay, this vertex is being mapped to this vertex, then this edge is being mapped to this edge, then this vertex is being mapped here, again this vertex is being mapped here, this vertex is being mapped here, this vertex is here, this vertex is here, this edge is here, this edge is being mapped here, and this vertex is being mapped with this vertex, and this vertex is being mapped with this vertex. So in two isomorphic graph we will have same number of vertices, we will have same number of edges, and we will have equal number of degree of each vertices. Like if we have three vertices whose degree is 2, if we have four vertices whose degree is 2 in graph G, then similarly we will have four vertices in G star also whose degree will be 2. So two graphs are said to be similar or isomorphic. Like in triangles also we say congruence. It's similar to that. Isomorphism is similar to congruence. Let's see another example. Here you can see the degree of V1 is 3. V1 is being mapped to U1 is T. U1 is being mapped to V1 here. Its degree is also 3. Then E1, we have E1 dash. Then we have U2. U2 has degree 2. V2 also has degree 2. Then U3. U3 has degree 3. Here also V3 has degree 3. Then U4. U4 has degree 3. Here also V4 has degree 3. And then we have U5 which has degree 1, and here also V5 has degree 1. So these two graphs are isomorphic with each other. So two isomorphic graphs have same number of vertices, same number of edges, equal number vertices with given degree. Okay, but converse of above is not true, that a graph with two graphs with equal number of vertices, equal number of edges, and equal number of vertices with given degree, but that graph may not be isomorphic. For example, if we see these two graphs, there are 6 vertices in this graph, there are 6 vertices in this graph also. How many edges are there? 1, 2, 3, 4, 5. 5 edges are here, 5 edges are here. Okay, so equal number of vertices and equal number of edges are there. If we see degree of U1, degree of U1 is 3. Here also degree of V1 is 3. Okay, so we have one vertex whose degree is 3 in both of the graph. We have two vertices whose degree is 1 in both of the graph. Here if we see this one and this one, these both vertices have degree 1. Here also we have two vertices whose degree is 1 in both the graph. We have three vertices whose degree is 1. U6, U2, U3. Here also this vertex, this vertex, this vertex. So 3 vertices whose degree is 1. And we have 2 vertices whose degree is 2. Here this one and this one has degree 2. So we have one vertex whose degree is 1 in both the graphs. We have 2 vertices whose degree is 2 in both the graphs. And we have 3 vertices whose degree is 1 in both the graphs. Even then they are not isomorphic. Why it's not isomorphic? Because the edge set is not being mapped. Here it's mapping here. u2 to u1, u3 to u1, but there is no such u2 u3 here, because there is no such edge, no such vertex whose degree is 1 here. With the vertex whose degree is 3, there is no such vertex whose degree is 1. Okay, so these two graphs are not isomorphic. So let's see this example. Which of the following pair of graphs are isomorphic? So to see this, let's just look at the vertices first. So how many vertices are there in A? 1, 2, 3, 4. So let's see the vertices vertices in all the graph. Here we have 5 vertices. In this graph we have 5. In this graph again we have 5. In this one we have 4. So E can be isomorphic to A. Okay, this graph again 4 vertices, so F can be isomorphic to A. This has 5, so this also cancel. Again this has 5, so this can be isomorphic. So either E will be isomorphic to A or F will be isomorphic to A. So let's see the number of edges. How many edges are here? 1, 2, 3, 4. 4 edges. 1, 2, 3, 4. 4 edges. 1, 2, 3, 4, 5. 5 edges. So EF cannot be isomorphic to A. Now let's see the degree of each of the vertex. This has 2 degree, this has 2 degree, this has 2 degree, this has 2 degree. This has 2 degree, this has 2 degree, this has 2 degree, this has 2 degree. So it's clear the 2 degree is being attached to 2 degree. Here also 2 degree is being attached to vertex of 2 degree. So this thing is getting mapped to this. Then we have this edge. Okay, so this edge is being mapped to this edge. Then we have this vertex. This vertex is being mapped here. Then we have this vertex. This vertex is being mapped here. Then we have this edge. This edge is being mapped here. Then this vertex is being mapped with this vertex. Okay, so similarly we have this, and then last this edge and this edge. So the A is isomorphic to E. Similarly, you can look for other pairs which are isomorphic. You can take the screenshot of this this slide, and you can work yourself to see the isomorphism. Next, homeomorphic graph. So what are the homeomorphic graph? If we have a graph G and a new graph is obtained by dividing all the edges of G with additional vertices, then the 2 or 3 graphs so obtained are called homeomorphic graph. In the given figure here, we have a graph C. We divided the edges of C into certain edges by adding some vertices. So we have added some vertices here. In this graph we have added some vertices here, and we have added some vertices here. So these 2 graphs A and B are homeomorphic with each other. Okay, and they are obtained from the graph C. So these are the homeomorphic graphs. Now what is a subgraph? A graph H is said to be subgraph of G if all the vertices and all the edges of H are in G. Okay, so if all the vertices and all the edges of H are in G, then H is called a subgraph of G. Like here you can see all the vertices and all the edges of this graph H are in G, so H is a subgraph of G. Here also vertices and all the edges of this graph are there in G, so H is a subgraph of G. Next is G minus V graph. What is G minus V graph? G minus V is a subgraph of G obtained by deleting the vertex V from vertex set V and deleting all the edges in edge set E which are incident on V. So if we remove one vertex, we get a G minus V graph. Like if we remove this vertex A. So this edge will be removed and this edge will be removed. So we get this graph. If we remove the vertex B, so this edge will be removed, this edge will be removed, this edge will be removed. So we get this graph. If we remove the vertex C, okay, so this edge will be removed, this edge will be removed, and this edge will be removed. So we get this graph C. So this is G minus V graph. Now what is cut vertex? Vertex V is called cut vertex for G if G minus V is disconnected. So if we are removing a vertex and corresponding edges are also removed, and after removing them the new graph so obtained is disconnected graph, then that vertex is called cut vertex. Like suppose if in this graph, if I remove this E, I get graph of such kind, right? If I am removing this E, I have to remove this edge, I have to remove this, and I have to remove this. So I get this graph, and there is no path from vertex C to vertex S. There is no path here. So this is disconnected graph. So such kind of vertex, so E vertex is cut vertex. Next is G minus E graph. A G minus E is a subgraph of G obtained by deleting the edge E from the edge set of G. So if we remove one edge, we get a G minus E graph. Like suppose here, if I remove this edge, I get G minus AB. I am removing the edge AB, I get G minus A. If I remove BC, I get this graph. If I remove BD, I get this graph. If I remove CD, I get this graph. Next is bridge. If removing an edge in a graph results in two or more disconnected graph, then the edge is called cut graph. So if we remove an edge and the resulting graph is disconnected, then that edge is called bridge or cut graph. For example, here if I remove this edge CE, I get disconnected graph. Okay, there's no path from C to E, there's no path from B to F, so these two graphs are disconnected graphs. So such kind of edge is called bridge or cut edge. Okay, next is union of two graphs. Union of two graph is nothing but just the union of vertex set and edge set. So if we combine all the edge set and all the vertex set, we get union of two graph. Like in sets, we take union, we combine all the elements of two sets. Similarly is the union of two graphs. And intersection also is nothing, just we take intersection of the vertex set and intersection of the edge set. Like here if you see, if I take the union, we have V1 here, so we will combine V1. Okay, we get this as union. And here if we have to see the intersection here, so we have only one point in intersection, which is V1 only. All other edges and vertices are different, so in intersection we get V1 only. The last thing, complement of a graph. So a simple graph with the vertex set same as a vertex set of G together with the edge set satisfying the property that there is an edge between two vertices in complement whenever there is no edge between these vertices in G. Okay, so what is a complement of set? Let's see in this example. If you look for V6 is connected to V2, V6 is connected to V4, but it is not connected to V1, V5 and V3. So we'll connect them. Okay, so in complement we'll connect them. So V6 is connected to V1, V6 is connected to V3, V6 is connected to V5. Similarly, V1 is connected to V6, V4, V5. V5 is connected to V6, V2, V4. V2 with V1, V6, V5 and V3. V3 is connected to V2, V6 and V4. And we'll remove these black lines. We'll remove these black line and we'll only take the red lines here. Okay, so we get this graph. And this graph G bar is the complement of this graph G. Okay. Thanks for watching this video. I hope you have understood these concepts. If you have any doubt, you can ask me. Thank you.